Hello everyone, in this video I'm going to show you how to find the inverse for this 2x2 matrix, and this process can be applied generally to any 2x2 matrix. So generally speaking, let's say we have the matrix B. It's a 2x2 matrix with entries A, B, C, D. Then we find the inverse by multiplying the matrix by a scalar, and that scalar is 1 over A times D, AD minus B times C. And we multiply the matrix, but not the same matrix, it's a different matrix. We swap A and D, so D goes up here, A goes down here, and we invert the signs of B and C. So B becomes negative B and C becomes negative C. So the matrix has an inverse if this piece right here does not equal 0. Well, you can think of it two ways. This here is the determinant, and any matrix whose determinant equals 0 does not have an inverse. Or you can think of it as if this is 0, then 1 over 0 is undefined, and we can't have that. And so that's how we know if the 2x2 matrix has an inverse. So in our case, let's go ahead and apply this procedure. In this case, this would be A, B, C, and D. So first we're going to find what A times D is. So AD, I'm just going to write it like that, 4t sine of 5t multiplied by our D, which is negative 6e raised to the 5t times sine of 5t. Negative 5 times negative 6 is positive 30. E to the 4t times e to the 5t, we add the exponents. 4t plus 5t is 9t. And sine 5t times sine of 5t is sine squared of 5t. And so that's AD. Now we need BC. So B times C is B, 5e to the 5t. Same process, so 5 times negative 6 is negative 30. E to the 5t times e to the 4t is e to the 9t. And then we have cosine squared of 5t. Now we have to find AD minus BC. So AD minus BC is 30e to the 9t sine squared of 5t minus B times C, we said was negative 30 minus negative 30 becomes positive. So 30e 9t cosine squared of 5t. And we can do a little bit of simplification by factoring out 30e to the 9t. So if we factor it out, we get 30e to the 9t times sine squared of 5t plus cosine squared of 5t. And we know from trig that sine squared of x plus cosine squared of x is 1. So we have 30e times 1, which is just 30e to the 9t. Multiplied by 1, it doesn't change anything. So now we have a value for AD B minus BC. The inverse of A is equal to 1 over AD minus BC, which we found to be 30e to the 9t, multiplied by our modified matrix. So D, these two swap positions, so I'm just going to write it like that.
6e to the 5t times sine of 5t. And our a goes down, so we have negative 5e to the 4t times sine of 5t.
And our B and C swap signs. So we have this, and we negate the bottom. Negative 6 negated is positive 6. Alright, so now we multiply the matrix by the scalar, so each entry has to be multiplied. So I'm going to write it out as such. Alright, so now we can simplify each entry. Negative 6 over 30 is negative 1/5. I'm just going to write the negative sign, and we know we have a 5 at the bottom. E to the 5t divided by e to the 9t means we have to subtract the exponents. So 9t minus 5t is 4t. And sine to the 5t just stays on the top. Now we do the same. Negative 5 over 30 is negative 6, or negative 1/6. So I'm going to write negative 1/6. And the same thing, e to the 9t minus e to the 5t is e to the 4t. And cosine of 5t remains on the numerator. Now this entry, 6 over 30 is 1/5. So I'm going to write 5 down here. And e to the 9t, e to the 4t is e to the 5t. And we have cosine of 5t on the numerator. Now this one, the last entry, negative 5 divided by 30 is negative 1/6. So I'm going to write 6 down. And 5t. And sine of 5t remains in the numerator. And this is our final answer for the inverse. So just to recap everything, the matrix has an invert, the 2x2 matrix has an inverse if the AD minus BC entries does not equal 0. And if you are familiar with the concept of determinants, you'll know that any matrix whose determinant is not 0 has an inverse. And that concludes this video. Any feedback is greatly appreciated. If you have questions, feel free to leave them in the comments, and thank you.